All right, we start again. Thank you all for still being here. I appreciate that. Those of you who have worked with me know that there's a department of deep thinking, and that department of deep thinking always works. And what you see here is the result of some of that. And given that you've been exposed to a whole lot of actual, real, good, solid progress technology in the past couple of days, and given that this talk is at the end of a 2-day session, the objective here is to look forward, to look to the future, and see what might inspire us, and see what might be a cause for deeper thought. So with that, we'll kind of pursue this. I am with a company called OrionX. We have an industry analysis technology strategy on the upstream. We do a certain level of market execution in the middle, and then we do customer engagement on the downstream. And you can go to orionx.net and read all about it. We do specially research on AI, on blockchain and cryptocurrency, which has been obviously getting very hot, and we have an increasing amount of content on that, trying to go a couple of levels deeper to understand how it works and why it works and for what purposes it works. And then we also do research on IoT. And of course, all of that runs on a foundation of cloud and HPC. We all grew up in HPC. Everything we do has to do with HPC, and you will see some remnants of that here. So I start with this, and I'm going to have quotes sprinkled around this talk as we go forward. So this one is one of my favorites. When things change, they're not the same anymore. It is very easy to consider change and feel like we are dynamically recalibrating with it as it goes along, but it's not, it does not change if it's not actually changed. And we are at the dawn of a giant change. And that giant change is basically the information revolution. We went from agricultural revolution to industrial revolution to information revolution. This slide was also presented last year. It's got a bit of a tweak. If you want to go look up my talk last year at this event, the objective of that particular talk was to make a case for why HPC is the engine of information age, why HPC is the engine of information revolution. And we're going to repeat that one too, but I'm just going to touch on that. So every time, revolutions are bloody, nasty things. Revolutions are no fun. There's a very funny segment in Homer Simpson cartoon series when they talk about revolutions, and that's always kind of a reminder of me. Go look that up too. But every time there's a revolution, there are some problems that get solved. There's some massive advance that takes place, but then there's also some problems that are created. So when agricultural revolution came about, it led to the agricultural economy. The social economic model shifted. We went from hunting to farming. It had an impact on how you plan things. People had to start planning. If you didn't farm when they needed to farm, you'd starve later in that year. It had an impact on family structure. It had an impact on how many children you were going to have because the farm has to get labor. And it had an immediate impact on governance. How are we going to govern ourselves? People were just stuck now in one place, so that soon led to the emergence of cities and such. Then the Industrial Revolution happened. Now, the gap between agricultural revolution and industrial revolution was long enough for a lot of things to settle down, for a lot of people to just kind of figure out how this new system works. Industrial revolution happens about 200-300 years ago, and we went to a manufacturing economy. The agricultural stuff didn't stop. That's how we get fed. So it became mechanized agriculture. And the problems that got created were, again, social economic model. We went from rural to cities. Automation came about in terms of activity and muscle. The muscle got automated. This time around is the brain that's getting automated, and that's why we're all freaking out. And automation was focused on action. And then what are the problems? Climate change is a remnant of that. All the smoke that goes up in the sky, it's going to catch up with us. It impacted on what jobs are. It impacted on money. So really, that's another thing to remember, that every time there's one of these revolutions, the meaning of a job changes. There was no factory job when there was no factory, right? So what are jobs going to be like when there is no factory, or when the factories are a very small part of what we all do on this planet. There's a redefinition of what money is, right? And we are now in the midst of digital money, and what the heck does that mean? And then the meaning of how you look at yourself. I mean, you could argue that the meaning of spirituality changes. You could argue that the meaning of governance changes. So those are like 4 or 5 giant dimensions that these things impact, which is why when things change, they're not the same anymore. We're all going to live a lot longer than we think, and we're not planning on it like that. Think that you're going to live to be 138 years old. I have to tell you about life is long philosophy that I have, right? So let's say life really is long. And think about when you were 5 years old or 10 years old, how did you think of your grandparents? You know, and then think how you want to be thought of as an older person. And things have really shifted quite a bit. And back then, they didn't know about, I mean, everything was organic anyway, but they didn't know about organic food. They didn't know about, you know, antioxidants. They didn't know about kombucha. They didn't know about hot yoga. They did not take care of themselves. You know, so let's say that you're going to live to be 138 years old. So most of you in this room, you're not even a third of the way there. You could do everything you've done, twice more, and have some room left over. Are we planning life like that? Well, maybe, maybe not, right? So now we're getting to the information age, which is kind of what we were just talking about. So that's leading to a service economy, but it didn't leave behind. It basically is going to lead to data economy, as I'm going to talk to you about later. But it is starting with a service economy, and that can be digitized and virtualized and all that. But it didn't leave manufacturing behind. That's now called digital manufacturing. It didn't leave agriculture behind. That's now digital agriculture. If you go to some of these modern farms, they're looking at a command and control system that is reminiscent of NASA. They've got, you know, screens, and, you know, every little percolation and, you know, water system is kept track of. They have drones running overboard, figuring things out. So all of these are really coming to take the previous advances with it. And then, of course, it's changed, leading to some problems. We've gone from regional to global. Globalization is a direct result of information age. There is a lot more awareness. Automation is about decision-making and the brain, not just muscles and actions. It has led to digital mistrust. We have witnessed it, and we continue to witness it for a while. And it has accelerated change because, you know, we had like, you know, good couple of thousand years between agriculture and industrial. Between industrial and information, it's only been a couple of hundred years. It's really, really fast. So this kind of highlights the importance of change and change management. Now, we're going to focus a little bit on data and another quote. So if you're not feeling discomfort, you're not out of your comfort zone, almost by definition. It is highly unlikely that you dynamically recalibrate and not feel the pain. You got to feel the pain, and those are sometimes growing pain, sometimes just because it wasn't very planned. So this is the proposal to how to deal with change. This also was showed last time as a bonus slide. So change is either desirable or undesirable, or this is my kind of attempt at a 2x2 for change. This is either unexpected or expected. If it's desirable and expected, woohoo, you probably planned it, more power to you. You can proceed to take credit for it. If it's undesirable and unexpected, it's pretty awful. And how do you deal with that? So, you know, maybe the way to deal with that is to get busy making it expected. And once you kind of make it from awful to bad, then you can have a smaller jump to make it desirable and good. But there's another quote coming to fix that in a second. Yeah, that was kind of the path, you know. If it's desirable and unexpected, you celebrate. If it's desirable and expected, you appreciate. If it's undesirable and unexpected, you reinvent yourself. So now this kind of brings up the concept of reinvention. If you're going to live 3-4 times in a lifetime, that means a couple of times of serious reinvention. And reinvention, once again, it's when things change, they're not the same anymore. So, you know, go put up half a dozen things that you'd wish you could do. Go get a law degree. You know, go open a flower shop. Go do, you know, there are lots of things that one can do. And that also, by the way, leads to a human being kind of going through the 1.0, 2.0, 3.0 phase of life. And when you get to your 3.0 phase, you're fully debugged, you're production ready, you've probably gathered a bunch of resources, you know how to get stuff done. So it's time to really have fun, right? So it's really cool, this whole thing, if it pans out like that. All right. So what is information age? It's obviously about data. So you extract the data, and that's digitization. You process the data, that's IT systems. You interpret data, and that's HPC, right? If you have 200 rows in your spreadsheet, it's a spreadsheet. If you have 200 million rows, it's HPC. There is no way to make sense of data without HPC. You could get lucky. Google has a I'm feeling lucky button, right? Try it, see if you get lucky. But most often, you kind of need real science. You kind of need real math. You kind of need to understand what you're looking at and why. And that is HPC, man, right? So I keep saying, as a community, we have to lead this charge towards information age, right? If this community doesn't do it, it's just not going to happen, right? So that's by itself quite inspiring. So now we go to the hot topics. What do we see that is kind of a topic? So the new world order, of course, is digital transformation, DX, right? I'm going to do buzzwordology here too. DX is the acronym for that. And digital transformation is complex, right? You have cloud computing, you have AI, you've got big data, blockchain, mobility, IoT, 3D printing, robotics, cryptocurrency, you know, boom, 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 boom. Now put yourself in the place of an average CIO, an average CEO, an average congressman, an average administrator. To put your arms around all of this is like impossible. There's no way. You don't have enough CTOs to go get good at everything, right? Let alone be able to arbitrate, let alone be able to advise and say, take this path and not the other path. So this truly is complex. And what cuts across all of it is security, right? Of course, you could argue that everything cuts across everything else and that you're just making the problem even more complex. But security for sure cuts across everything. So let's kind of see what this means and try to simplify it in the interest of time. Oh, there was more animation here. So what is the future? The future is IoT, blockchain, quantum, AI, where machines, bots, DAOs, that's for decentralized autonomous organizations, and dApps, that's decentralized applications, distributed apps. Now, a lot of this to HPC guys is like a duh because we did it 10 years ago, but you have to wait for the rest of the group to catch up, where these guys do most of the creating, consuming, and paying. So imagine that you're at the edge of a pool, and this is the digital soup that's going on, and around this digital soup, a handful of people are standing, right? 95% of the action is going to be in the pool, right? And this is a giant difference from where we have been and where we're going. The activity is all done by digital people. So when you see digital money, it's no longer for me. The digital money is for things to pay each other, right? At some point, I get a glimpse of it if I'm at the edge and I can grab, or if it comes to me for whatever reason, right? But you have to think in terms of digital entities are having their own life, and they're all doing their own stuff. They're doing it on our behalf, but we don't even want to be in that kitchen. Let's just let them go do that. So that's, I think, the picture. So we're going to go look at each one of them. IoT. So IoT is really about data economy. Think of things, these are atoms, and think of information, these are bits. The interaction between bits and atoms is the issue. And this is really where the crux of the matter is, that this layer that connects the atoms and information to each other is the hardest bit. Within bits, we kind of know a bunch of stuff. This whole digital stuff is happening. Within atoms, we know a lot. We know supply chain, we know manufacturing, we know inventory turns, we know how to pay for things, we know quality control, we know Six Sigma. All of that is like solve problems, right? And then you get to the atoms, and then the interaction between the two is really where a lot of the action is. So think about that. What happens in the middle of that is the data economy. So today, you just want to connect your coffee maker to the internet, right? Or your car to the internet. Tomorrow it's the data that comes out of it that is in fact the real deal. So some of you know that I used to work for Sun Microsystems, a company that we all still love very much. So we were meeting with folks from a major auto manufacturer. And their kind of telemetry was running on our equipment. So the question was, how much do you need to charge for a car per month for that service to be able to give away the car for free? Assuming that the car was going to be running for 5, 6, 7 years, right? So you can do the math. Take a $50,000 car, $35,000 car, give it an average age of like 6, 7 years, make it so that it doesn't even operate if you're not subscribing to this service, right? And then see what those payments come out to be, right? So think about that. So suddenly the thing kind of stops mattering, and the data coming out of the thing is what really matters. And there are people who figure that out, right? Google has figured it out. Facebook has figured it out. Obviously, like Nielsen rating had already figured it out years ago, right? So, and of course, it leads to the data supply chain. So we have the actual supply chain for physical stuff, and this is the data supply chain. So you got devices that are basically data sources. You go to the data supply. You go to data product. That's where applications are. Applications are just kind of part of the data supply chain, transforming data from one format to another as they push it towards a data product. And then the data product goes to data consumption. Eventually, that leads into a data market. And of course, the governance of that market becomes an issue. HPC, so this is this kind of slide that you had last time, is the engine of the information age. And I'm just going to run through this. So if you have digitization, you get data. If you get data, you need STEM and IT to figure it out, and that's HPC. And if you look at what sort of, this is the diamond I've been showing for a couple of decades now. You got automation, instrumentation, visualization, simulation. You start on this end. Maybe I should have let it animate. But you start on this end with theory, experiment, simulation. That's kind of what we know, the 3 pillars of science. And then the simulation gives you a new way of doing things. You can automate that. You then instrument that. You get new data. Then you get visualization of that data. You communicate in between, and that leads to new simulation. So this kind of becomes a virtuous circle with HPC. Now, a big piece of what we do is the sources of data. So in order to do sources of data, I'm going to take you not through every one of them perhaps, but these are my big rules of big data. There's another one that I need to fish up that I tweeted a couple of weeks ago, but didn't make it to this slide. So data is cheaper to keep than to delete. So think about that. The fact that data is cheaper to keep than to delete is the reason why all this data is gathering. And actually gathering in triplicate, right? If not more, right? When was the last time you deleted anything? And when you did, it was probably like, with trepidation. What if I'm going to need it later? I'm just going to keep it, right? Whatever caused you to collect data will cause you to collect even more data. Because you're going to start collecting data, and it's going to feel good. You're going to get all this data, and you're going to get more of it. So there's really, it's no stopping. Second, big data systems start small, they show promise, they go big. There's no middle. So we've done some studies. Big data clusters are either tiny or giant, right? They're not that many that are like in the middle. You start with like 8 nodes, you go maybe 32, 64, then boom, it's like 2,000. Very, very, definitely a bimodal curve. Data must flow to be valuable, right? Just how valuable is a function of the context. So now that gives you the content and the context. So now you kind of start feeling relativistic, and it's like, there's in fact a actual research called quantum storytelling, where you get the data and you kind of tell it in a different way. Never assume that you know what is cause and what is effect. Right? Because every time we assume cause and effect, it basically means that we've put a circle around our scope and we're limited to that scope. What happens outside of that scope is actually quite important. And that really leads to a big truism in AI that you can only automate what you can precisely define. And if you go step outside of that scope, you're not going to be able to do that. What is that? Number 6 is the one I like, so I'm going to, the ratio of relevant data to irrelevant data will asymptotically approach 0, which means that finding the needle in the haystack is just going to become harder and harder, because there's only one needle, and there's a lot of accumulating haystack. The ultimate purpose of analysis is synthesis, so think about that. We talk about analytics, we really should be talking about synthetics. because analytics is like not interesting. Synthesis is really what gives value to data. And it's a different kind of activity. It's a different kind of brain. People who are very analytic may not be very synthetic. It's kind of creativity required. All of that, remember that. This one, number 9, I will go to. Volume, velocity, variety, value. These are all very good, but they're balanced with irreproducible, irrelevant, incomplete, incorrect, right? And of course, that leads to number 10. Given enough data, you can simultaneously prove opposites, right? So it's like, the old adage that, there are lies, damn lies, and statistics. Right? You can prove anything you want with enough data. And that also leads to that other quote that if there's a will to condemn, the evidence will be found. It works in all directions. So one has to be careful of that. Okay, sources of data. This is really, really important. The sources of data traditionally was organizations. This is what led to a $50 billion IT market. Organizational data. Then Facebook shows up and Google shows up and they enable a new source of data, people. So people data has now led to a big giant market and they know how to monetize it. What is really happening now is a third and fourth sets of data sources, and that's things and systems. So the reason IoT is a giant big deal is because it's enabling new sources of data that are way more numerous than organizations and people. Maybe there were 100,000 organizations. Make it 1 million organizations. Make it 10 million organizations. But there are 10 billion people, 8 billion people, right? And there are 100 billion things, and they're growing every day. So enabling things as a source of data is a huge impact to the IT world in general. And what do you do with that data? You have to extract the information content. You have to give it structure. You have to then apply apps and put it into data supply chain. So that's kind of the model that we're thinking is going to happen. And you could render this 3 different ways, depending on whether you want to make the sources of data 1 or 2 or 3 or 4. AI. Now, I said this last time, and I think this is more or less the same, a little bit different. But AI really is high-performance AI. Let's not forget that. AI has been around for 50, 60 years, and it was kind of not interesting, right? Then people figure out to do deep learning, and then boom, it takes off, right? Okay, folks like NVIDIA were there to greet it, and they've done a great job leading it. They're like, at this point, we're counting on the order of 30 different AI chips that are either designed or in the various stages of development. So obviously, people think this is big enough to kind of invest in it at that level. But really, you have to apply those big rules of big data to AI. Otherwise, what you're automating may not be the right thing to automate. And if you look at how it kind of works, you have IoT feeding the data, and that kind of your big data, and you got numerical side and the logical side, and you combine the two to kind of do the real AI that's needed. But this is fundamentally HPC, so we keep calling it HP AI. Blockchain. So blockchain is like watching an Ingmar Bergman movie. You know it's important, but you don't get it. And it's very true. It is a rabbit hole. If you haven't taken the time to go through that rabbit hole, I highly encourage you to do that. This is the kind of community who really needs to do that. Because we need to get it, and we need to get it in a coherent, solid way, not just through the hype, right? So the reason why blockchain is important is because it's about decentralization. So I call blockchain the CC NUMA of transaction processing, right? It's the scale-out of transaction processing. And when we went clusters, coherency in the cluster was relegated to the application programmer. When we went to CC NUMA, the coherency, the system would do it. The only problem is that in CC NUMA, CPUs don't lie to each other. Whereas in real world, you have to build a system that is taking account of the nodes misleading each other. So this leads to the old Byzantine general problem in networking, and therefore consensus algorithms. So I'll go from bottom to top here. But fundamentally, it's about the kind of coin. I'm really trying to simplify it here. But let's say you have kind of either an equity coin or a utility coin. Utility coin kind of makes it into a currency that is either limited or public. On top of that, you have the consensus algorithm. So the consensus algorithms are different, right? Bitcoin has a consensus algorithm. IOTA has a different consensus algorithm, based on directed acyclic graphs. There are, hash algorithms. So there are different levels of consensus algorithm that attempt to make it different levels of airtightness in terms of trust. On top of that, you're getting so-called layer 2 technologies. The most notable of that is Lightning Network, that essentially says if I'm kind of got this global network, maybe there are things that I can do locally. Maybe there are things that I can just kind of arrange between the people who want to do it, and I can still achieve the trust that I want, and I'll come back and batch them together and manage them later. But that has led us to, when are you supposed to use blockchain? Because there are problems. If you're doing, let's say SMP versus CC NUMA versus cluster, and let's say you have the option for all of them, it's going to depend on your application. There are things for which existing methods of doing are just fine. So we think that you need natural scale. It needs to be naturally distributed. You need to have a problem in terms of traceability or rights management. And you need participation, because you can't have a whole network where only 5 people participate and try to kind of be the arbiter. Everybody kind of, or at least a fraction of the network needs to participate to do that. But the net result of it is that trust becomes computable. So if AI made intelligence computable, blockchain is making trust computable. Whoa. So now you have decentralized trust. So now you can think of anything that is centralized and say, oh, I can do that in a decentralized way. I can have a decentralized Facebook. I can have a decentralized this. I can have a decentralized that. And then eventually say, oh, I can have a decentralized central bank. And I'm going to do my own currency, and it's going to be the whole global thing, right? So this is why people are pouring money into this. It's not because they're consumed with the hype. Like some of them are. But the smart money is involved here because they are after decentralized trust. Okay? Just like the AI guys are after computable intelligence, these guys are after computable trust. And then we get to quantum computing. So I made it to the tail end of the talk yesterday about quantum computing. And yes, it is too early, right? It is way too early. Having said that, the progress that's happening in quantum computing is faster than expected. So it is like, whoa, this is really cool, right? And everybody's doing it. Everybody who can afford to, everybody who cannot afford to, both sides. Those who can't afford not to do it are doing it, and those who can afford it are doing it. So it is hot, and it will remain hot for the next decade. Every startup that gets into quantum computing is raising $60 million, $120 million. These things are expensive, but then the impact can be huge too. And if you're a big fund, where else are you going to put it if you got the right people? But it's also governments around the world that are interested in this and are, directly or indirectly pushing it forward. And we have moved from, is it quantum computing or not, to, well, what can it do for me? I don't care what it is. If it's going to make it go 6,000 times faster, I'm interested, even if it's not quantum computing. So I think we've moved beyond the semantics of what is or is not quantum computing. And then I leave you with the 3 buzzwords of quantum computing today. One is quantum supremacy. You probably know all of this already, but that's when quantum computers become faster than traditional computers. Probably not for PowerPoint, but for some actual computation. Y2Q is year to quantum. So year to quantum supremacy is the measure of how close we are to this. For example, Y2Q for quantum chemistry may be 10 years, Y2Q for prime number factorization maybe 20 years or whatnot. So you measure these Y2Qs for specific applications. And then quantum safe cryptography is a really big deal because a lot of what's going on in the digital world is relying on the 256-bit or beyond for those who can do it, hashing algorithms. And if the prime numbers can be factorized faster, that can be decoded. So there's been a lot of, believe it or not, I mean, when we started researching this, there are like books written on quantum safe cryptography and research projects that have been going on for like a better part of a decade. So this is not new thing for those who've been paying attention to it. They've been expecting it and they've been trying to work on it. And I think that may just be the last slide, so I'll leave it with the last quote, which is, change is best when it's your own idea. And who decides it's your idea? You do. You flip the switch. You say, it is now my idea. You can do it by declaration. There's no identity crisis needed. You just say, now this is my idea. The moment you say that, suddenly change becomes a great idea, because now you're the change agent rather than, right? Yeah. So I highly recommend that. And thank you. Questions or stun the silence, please?
Yeah, there are two very common for blockchain. Yeah. And some people believe that Bitcoin will reach 1 million at least.
They do, yeah. John McAfee does.
Also, maybe 99 experts, they say that ICO, 99.9 ICO is correct. It's
Yep.
all cheating like that. So, what do you
Comment. So the questions were, one, some people think Bitcoin is going to go be $1 million per coin.
Yeah.
It's now hovering around 10,500. Last year this time, when I talked, and I had a slide on Bitcoin, it had just broken $1,000.
Yeah.
Right? So if you all had gone on 10x, not bad. So it went up all the way to $20,000. It went back to $6,000. It's now gone back to about $10,500. So the question is, why did it go up? So we have to preface by we are not investment advisors, and this is not investment advice, blah, blah, blah. So all of that disclosure aside. So the reason why, in our opinion, it went up is because there was demand. It was being made available in more and more people, so there was actual demand. So second, Bitcoin is very limited supply. So the supply of Bitcoin is capped. We have not reached to that point yet, but it's trickling in, so it is substantially already available. So think about it. You have a commodity whose supply is limited, whose demand is growing, whose accessibility is growing. So people could go to Coinbase or Bittrex or Poloniex or these other exchanges and just set up an account and buy, right? So it was becoming easier to actually buy. And then three, the legal environment at the time was pretty neutral to kind of encouraging. And the legal environment has been the wild card. Every time some country or some state makes an announcement, people react to that, right? But as long as demand increases and supply is limited, you expect the price to go up, which is exactly what happened. Unless you kind of put the fear of God in people and then they back off. So right now we are in that zone that people in different countries and they're trying to figure out how to regulate it, to what extent to regulate it. Some of them are more thoughtful than others. Some are recognizing that this is really a big deal and maybe in the proper ways it needs to get encouraged. Some people say, ooh, if this is something new, maybe I want to use it as a vehicle to achieve my own objectives as a country, as a community. So I think that's where we are. So those who think it's going to go to $1 million are betting on the legal environment to neutralize and be okay. Secondarily, all of that aside, is what is the use for Bitcoin, right? Bitcoin essentially has become digital gold, right? And so the main use for Bitcoin right now is digital gold. And if you're a really rich person and you consider Bitcoin as a new asset class, then it is highly reasonable for you to say, maybe I do need 5% of my assets in this particular category as a way of diversification, right? And if you're rich enough, that 5% could really move the market. The second use case for it is that it's a gateway to all these other coins. Last year this time there were about maybe 1,100 coins. Now it's upwards of 500 to 1,500, 1,600 coins out there. And as you said, most people don't do research. If you want to do real research, you go on the coin, you go to GitHub and look at their code base. You see how many changes have been made, who the developers are. But fundamentally, what is the use case? And is this use case blockchain ready? Is this a use case that should be blockchain, or could it just be done with an existing database, right? So if you do that, you're right. A whole lot of coins, that was the second question, that most of these coins are just not very good, shall we say. And indeed, that's the case. Some of them, at the end, you kind of are making a bet. So the second thing is really the use case. What is Bitcoin being used for? And that is also where some people have a problem with Bitcoin specifically, that those particular use cases are not enough. It was initially built as a currency, but people really don't want to use it to buy coffee anymore because, that you don't want to have a $200 cup of coffee if you just held on it for 10 more hours, right? You also don't want to have, this has happened to, people with like stock options, where you say, oh, let's go, cash out the stock options, and then 5 years later, you're looking at your $200,000 couch if you just held on it, right? So that has, now, at the same time, transaction costs kept going up, but also a lot of technology is being built, like this layer 2 technology that's kind of bringing down. The consensus algorithm have changed with segregated witness rather than just, before the block sizes have been getting bigger to try to facilitate that. So very much Wild West, very much we still don't know. But the underlying algorithms, the decentralized trust algorithms, that is unmistakable. Exactly where it gets used and how it gets used is kind of anybody's guess. So as a result, some people liken blockchain cryptocurrency to the early days of the internet, right? So imagine it's now 1995. Java is still new. Everybody starts having kind of, the sun says we are, dot and .com. Who would have guessed that fast forward, the winners were going to be Amazon and, eBay and Google and Facebook, right? So those are the early days, and it will happen. Yeah. Please.
The problem with blockchain, obviously I didn't understand it, otherwise I would be rich, but is the problem that humans got involved in a normally machine-to-machine currency that was proposed to have fast transaction from Europe to Africa because you don't have to have this fees. But if you only hold on to Bitcoin for a sub-second, then you don't have money fees to supply, right?
Well, moving digital money costs money, just like moving actual money costs money. But it is way faster. You can really literally do it in minutes rather than like 5 days, especially if you're doing it across countries. So if you look at all the startups that are in payment through blockchain, they are focused on international money transfer because that's the real pain point.
Western Union kind of.
Well, I don't know how well Western Union does international borders, but I know it's not cheap, right? And if you've actually formally transferred international money from a bank in, some part of the world to another part, it's time consuming, it's expensive, you have to wait like a week, and why is that, right? So there are people who use it for money transfer and they really never hold it, right? They just convert, transfer, convert back. And if you do that, then maybe you kind of don't need to worry about the risk of it, spiking or not. You still have a risk, but so that use case continues to exist. And there are people I know who have got into Bitcoin accidentally like that because they just wanted to transfer $10,000 from here to there and say, why am I not doing it this way? And they were technical enough to kind of figure it out and do it. And then, so they were early, and I hope they bought a lot and held. Very good. Time to go? Very good. Thank you so much.